All right, so I'm going to introduce to you all our final speaker of the day, and our speaker is Dan Hauser. Dan, you're up.
Well, thank you all. Thank you. So I have the difficult position of standing between you and beer, discussing the exciting topic of cryptography. So that'll be a bit of my challenge today. But hopefully you'll find this interesting, or at least better passing the time than being tortured to death. So we're going to talk about cryptography in the real world, and I sound like I'm a little live, a little hot. I don't know if it's just me, but we're going to talk about some real-world cryptographic implementations, some case studies, some lessons learned, and to balance security with expediency, and is what we're kind of talking about. So I like to call this as a joke PKE. That's public key enough, right? We don't need super-duper cryptography. So if you work for the federal government or any government, this talk's not really for you, okay? Because you have enough resources to invest a lot more than the rest of us. But so this does not represent any real-world cryptographic implementations by my organization or our clients, nor our existing engineering and policies. They make me make sure I say those things. Cryptography is tricky stuff. It merits a lot of due diligence. So please show that appropriate due diligence. And this presentation isn't a complete guide. Hire an expert. And you remember the movie Castaway with Tom Hanks and how ill-advisable self-dentistry is. Self-cryptography is often as advisable as that. So hire an expert if you get nothing out of this. So scenario number one, interactive moment here. You're working with some developers, and two of them come to you with a question. This first says, okay, we're sending these files across the internet. One, we want to encrypt the file first, and then we generate hash and sign that, and that's what we want to send across. The other one says, oh, no. We want to generate the hash and sign the hash, and then encrypt the whole package. Well, which one's right? How many of you would say that A is correct? And you have to vote, right? The camera's pointing this way, not that way. Nobody will know. All right, so who would say A? Who would say A is correct? How many? That's a lot of B's. Okay, that's what a lot of B's. Everybody else is B's? Most of you are not voting. Okay. So who is right and why? Well, it depends on your business case, on the use. And of course, if you generate the signed hash and then encrypt, well, then nobody can tell who's communicating, but you really can't segregate the functions. The guy who's actually processing the file will then have access to the sensitive data. Do they actually have a business need to know for that data? But it does make it susceptible to denial of service. And okay, if you take the other route, then you have the ability to segregate that. But then somebody can find out who the sender is because it's signed, right? And so there's this quandary, and your business requirements should dictate which path you take. But I led you down the primrose path because the actual answer is, are you nuts? You should not create your own cryptography. This is not a rational act. So do not develop your own secure communications code. Buy something, right? Buy commercial off the shelf, PGP, GPG, SSH, AS2, AS3, many other ones you should use first. And by all means, do not develop your own cryptography. You get nothing else from this. Please get that. So I'm going to go over how a lot of folks tend to ask the wrong questions. And so a lot of crypto failure modes, rather, sorry. And the first of those is by asking the wrong questions. Probably the most famous and horrible question in cryptography, or in information security at whole, is it using SSL? I don't know how many times I've been asked that. Now, paradoxically, I realize with TLS 1.2 and now 1.3, paradoxically, this has actually become a good question. Like, it better be not using SSL, right? Like we want to use TLS, but this has been used for so many years as this magic elixir we're going to pour over the project and everything is fine and safe, and perhaps one of the most overused auditor questions. But it checks the box, and so it's easy. But TLS is a pretty weak control. Look, it does two things. It authenticates the server to the client, essentially, right? Yes, there is bidirectional, of course, but in most cases, it's to authenticate the server to the client. And So why do we still have phishing? I mean, so it's kind of a fail in that regard. At least when you're intentionally communicating with them, you know it's them. But it's not going to solve all your problems. And it's providing link-to-link confidentiality over on trusted networks, which until about, I wish I knew the exact date, about 7 or 8 years ago was the very first time we actually had a massive attack that actually sent a whole bunch of traffic off to Eastern Europe and back again. And it was the first actual known instance of there being capture of packets live over the internet with the redirector. But almost never happens, right? It's an extremely improbable case. And so if you actually look for the ROI for that second use case of protecting your data across the internet, you're not going to be able to do the math because it's like, it's well below a penny. But it is lawyer repellent, so there is that. And I'm not saying don't use TLS. I'm saying this is a bad question. One reason why it's a bad question is a quick case study. Is I was working at an insurer, and the network team wanted clear text between two servers. I mean, they are literally in racks within 10 feet of each other using fiber in the same data center, right? And you have all the sort of protection in the data center and armed guards and everything else, right? And so it's only going like 10 feet. And the auditor says, yes, but it's not encrypted across that link. You must encrypt that. You have to use TLS. And the guys are like, the load balancers are a little flaky. We actually need to see that. So no, you have to do it. So they implemented TLS null with null null, which of course is called clear text. Yes, they did in fact implement TLS. And in the end result, they actually made the solution more complex with absolutely zero benefit, right? And they were snickering behind their hand. Yes, we implemented TLS, but they really hadn't accomplished anything. So they made the auditor happy, yes indeed. But when we actually looked, it's like, why am I seeing data with this as TLS? I'm seeing the data. So the auditor specified controls he didn't actually understand. There are lots and lots of better questions we can ask, like what are you protecting? What's the value of what you're protecting? What's the value to the attacker of what you're protecting? What role does cryptography play in the design? What role should it play in the design? What's the level of assurance needed? How are you using TLS is a much better question than are you using it? And do you have a key management life cycle, and are you actually testing these things in your operations? What can be redacted, deleted, or anonymized in the data that would make you not have to use cryptography at all, right? And over what period of time must it be protected, and does the value of the data decline or increase over the period of time? Stock quotes only have to have integrity for a few minutes. Now you probably need to prove that you gave an accurate stock quote. Maybe that's a longer duration, but do you understand the business case for it? What's the threat model? How will you test it? What's the DR plan? Are there operational run books? Has anybody actually tested the replacement of keys? And the infamous issue of your certificates expiring, right? That's probably as important to the rest. And auditors don't tend to ask all those questions. I'm not throwing a rock at auditors. I'm saying there are better questions to ask than is it using TLS. Another failure mode I see is, and by the way, I am not a cryptographer. I just have dabbled in the art for a while. But algorithms are not as important as you may think. And I know this is heresy, that first line, you're going like, no, AES is so much better than DES. Well, what I'm saying is, a quote from Bill Murray, this is not the actor, this is Bill Murray, one of the founders of ISC2, and also known as the father of information systems audit. And he was one of the people that actually helped give us RACF. He said that the use of DES is the weakest control. You have a very secure network indeed. And it's a pretty good statement, right? And I'm not saying it's not important at all, but we spend so much time arguing over protocols and algorithms, and we don't talk about testing and validation and implementation and operations. We don't talk about continuity management and failure modes and all the rest of what's in the system. And don't argue so much over the protocols because nobody brute forces crypto, okay, except governments and wares and media pirates. They do. I had a conversation with Ben Jun, VP of Cryptography Research, about this, and I asked him if they ever brute, because they're paid by people at least. Well, Ben has moved on to a different job by now, but the organization is paid to break crypto systems and and then armor crypto systems. And he says, yeah, we always cheat. We never break the crypto. We go after the algorithm. And would you rather try to break AES or try to phish a user or defeat key management or sneak in with a USB driver? Any number of ways you can attack a crypto system besides going after AES. I mean, I wouldn't choose that as my path. That's not a rational choice. So nobody brute forces cryptography. Crypto systems fail due to implementation flaws. If you look, and this is very useful, I'm not a shill for Veracode, but they do publish the State of Software Security. It's a pretty good guide. And the number one failure in Python for 5 years in a row is a cryptographic failure. And it's in the top 5 for all languages, if you look out at the guide. And authentication errors is always in the top 5 as well. So neither of those stands us in good stead. And you look at WEP, not that I'm saying RC4 is freaking awesome, but it wasn't RC4's failure that caused WEP to fail. It was an implementation error. Enigma with 4 rotors and the plug changes was a very strong crypto system, but the Germans got a little sloppy and they chose keys of HIT and LER, or BER and LIN. And yeah, you do stupid things like that. Stupid decisions yield stupid problems. Those are all just failed implementations. But let's not be stupid. Okay, cryptographic algorithms do matter, but they don't deserve a long conversation, right? There's a real good reason why cryptographic algorithms undergo years and years of scrutiny. And as we saw, we actually got through the second round of quantum safe cryptography, and one of the contestants failed catastrophically, be broken by a laptop. It was like, whoa, how'd that happen? Well, this is why they do the testing, right? So I've seen folks use some of the additional ciphers that didn't quite make the list, like Twofish or Serpent or Cube Hash, and those weren't certified. So use AES, not the ones that lost the race, and use SHA-3, not the ones that didn't make it. The Japanese government has come up with Camilla. I think there are others as well too. Those called vanity ciphers, and they are available for you to select in what you will support in your sessions with TLS. But why? Any browser users are using will not say no. I can't connect with you unless you use Camilla. So yeah, stick with proven ones that are certified, and don't go the dark path there. But if you look in the same State of Software Security, 38.8% of Java softwares with a new CWE in the last year had a failure of bad or broken algorithm. This is a cryptographic failure that is super simple, like why are you using ROT13 or whatever you used, right? That was completely not strong cryptography. 38.8%. That is a huge number, right? That's a little scary. So there's obviously some work that needs to be done with developers and helping them understand. So that gets us to cryptographic standards. Does your organization have standards for cryptography that are published, that your developers know? If you ask them, can they find them? That'll tell them, yeah, we don't want you using SHA-1 or MD5 anymore. And there's a real good reason why. Here are our standards, and here are ones that are non-standards you're not going to use. And there might be some that you have to use if there are some old creaky browsers that you must support based on your global footprint. So, like Windows 7 is one of the ones. It should die, but if 18% of your users are using it, then there are a few squeaky algorithms you're going to have to use that aren't great, right? So there are maybe some that are on the list, like by exception only, but we don't like these ones, right? But when was the last time you reviewed this? Is it looked at annually? Is it part of the training that you have? And are you actually scanning for this? I actually went to an organization once, and they actually had a list, but when we scanned, they had SSL v2 active on the internet. No, I didn't stutter. I didn't say v3 or v2 by mistake. They had SSL v2, which was broken in the lab. Like, it never should have left the lab. It was decertified before it ever went live, and they were using all crypto modes, including like DES40, that was the intentionally weakened DES for export when we thought nobody outside the US could do math. And Yeah, and so like, guys, why? You have standards. What are you doing? So, just having a standard but not actually scanning and looking for it is not doing any favors. Another failure mode for cryptography. Cryptography is seductive, and there's the Dunning-Kruger effect. So cryptographers are smart people. However, smart people are not cryptographers. The reverse is almost always wrong. I've heard all of these. They're a rated chess master. They're a physics PhD candidate. They're a programming genius. Great, good for you. That doesn't make them a cryptographer, right? Snipers don't build great bulletproof armor. They're very familiar with it. They know how to defeat it. That doesn't make them armorers, right? Truck drivers, intimately familiar with bridges. I don't want to drive over a bridge designed by a truck driver. Just because they use it all the time doesn't make them an engineer. So familiarity with the space does not make you a cryptographer, which is why I told you I am not a cryptographer. It's a very specialized skill. So another hash case study here is we were engaged with a commercial SaaS provider, and they had a one-way hash that was irreversible. And they were using it so they would be able to send documentation out to their customer base, and they'd be able to print a hash of their social security number that they could use for a business function to be able to provide the social security number hash without actually sending out their social security number in the clear in that way. And they had this permutation cipher with algebraic transforms, and the programmer was a physics PhD, great, not a cryptographer. And we looked at it, what it was, and this is simplified a little bit for clarity, but really not very much at all. I mean, this is basically really close to what that was. I just, for the sake of NDA, switched a few things around, but it was essentially really, really close to this. And so if you notice what they were doing is they're taking the integer values, so positive only, absolute values, so integers only, of a mod 10. So at the end of the day, what they're saying is I have these different inputs, and what comes out will always be a positive single-digit integer, okay? Which I looked at and said, well, that's kind of funny. So my boss gave me a challenge, and he said, okay, I'll give you an hour to break it. It's like, I'm not a cryptanalyst. It's like, this seems really, really weak. Look at it. So I looked at it, and I sorted it based on the complexity of the algorithm. And I first of all noticed d prime, which you'll see is 2. Oh, that's the integer of the absolute value of the modular base 10 of a minus. Wait, I know what a minus 7 to give. Okay, a has to be 9 because something taken away from or 7 taken away from a number that gives you 2 is obviously 9. Oh wait, I know the value to plug into the next one as well too. So that means b is 3 and c is 8, and on and on and on, and the entire thing was rolled. I didn't even have to use any tools. I mean, this was like pencil and paper. Like, oh, dude, this is like algebra. This is like stuff I was in 7th grade, right? So a little scary that they were unable to see this own flaw. So I broke it in about 20 minutes with pencil and paper, not because I'm a genius, because it was just that bad, right? And they had, whoops, wrong button. Okay, and they had created a problem they themselves could not see. So mod 10 ensured it was really easy to break, perfect plug and chug formula, right? Not even as hard as the cryptograms in the paper, and easily reversible. And I spent the next 40 minutes I was allocated coding it all into Excel because I knew what would happen. He would not believe me. I would say, okay, give me the hash of your social security number, and he gave it to me, and I immediately read it back. Not because I'm a genius, it was just that bad, and he couldn't see the flaws. He was devastated because he thought he did something really cool. Well, he did do something really cool, but it wasn't secure, right? Yeah, okay. It looks smart and complex, and his diagrams, like my eyes glazed over at first. And I actually was at a cocktail party and talked to Ben John and Paul Kocher. Paul Kocher's like the guy who ran the SSL project, so he knows cryptography really well. He is a cryptographer. And they both said, why did you just use SHA-1? Right? What? SHA-3? Something. I mean, take the least significant digits off of a standard hash algorithm, and you're there, right? Why are you doing this fancy thing? Okay, so failure modes here, Kirchhoff's principle, which is that the security relied on the secrecy of the algorithm, not just the secrecy of the key, right? Kirchhoff's principle is you have the complete diagram of the safe, And the only thing that should defend the safe is the combination. And knowledge of how the safe was constructed should not matter at all. That's Kirchhoff's principle. Schneier's law that everybody is capable of writing a cryptographic algorithm that they themselves cannot break. Of course, the trick is doing it that nobody else can break. That's substantially harder. PhD in physics, not a cryptologist. And there was no avalanche criteria. Avalanche criteria is where every bit of the output is dependent on bits of the input. In fact, there were several multiple independent variables, so it completely failed on that. Single-digit ints, as I said before, the real sin in this laundry list is creating your own primitives and your own implementations. Just use commercial and you're done. So the Dunning-Kruger effect. This is MacArthur Wheeler. How many of you have heard of MacArthur Wheeler? Yes. The bank robber who in 1995 robbed 2 banks and had sprayed lemon juice on his face, believing it would make him invisible to cameras. And he was apprehended that evening by the police. And when apprehended, he incredulously said, "But I wore the juice. Like, how could you possibly see me?" Professors Kruger and Dunning actually wrote a paper talking about this and how difficulties in recognizing one's own incompetence lead to inflated self-assessment. And this is the bear trap of cryptography for so many. So many have fallen on this hill. And that is that at the beginning of your knowledge, you seem to learn very quickly and you think, oh, I get this. No, you're spraying lemon juice on your face. This doesn't actually work, right? So you're at the peak of Mount Stupid. And as you start to gain more knowledge, you realize how little you actually know. And then there's a slow climb until you actually can and should do cryptography. And there's a whole lot of peer review and a whole lot of folks that are ABD and never get out of that and decide they're going to do something else because it turns out that crypto is really freaking hard doing it right. At least doing your own ciphers. I mean, that is rarefied air. Details matter, so don't lose sight of the goal. And for all of you OCD folks, I do apologize. It's been driving you crazy. Yes, that is not actually failure mode 3 or number 6 because details matter. So for those of you that sat through the last 2 of those saying, but this is not number 3, sorry. But the corollary to this is not everything an auditor suggests is right. Another case study, death by audit. I was at a major financial firm, and the mainframe application was predicted by RACF. Now, any of you, how many are familiar with RACF? All right, I see very few hands. Okay, RACF. Oh gosh, I don't remember what that stands for because it's been so long. Anyway, it's an IBM product that provides for access control for mainframes. And ACF2 and RACF are the 2 dominant players. RACF has been around for, 40 years. And it's a great commercial product. And, it's been tested to the nth degree. But the mainframe says, or the auditor says, hey, the mainframe doesn't recognize substantially similar passwords. And Smith 001, Smith 002, they could do that, and you're not detecting those. So you need to make sure those are substantially similar passwords are checked for. And then the developer said, okay. Well, hey, I know what we'll do. We'll use the best cryptography because XOR, the one-time pad, never been broken. It's perfectly secure. So that's what we're going to do. And we'll XOR the password with the password last change date, not date timestamp, date. So today's would be 09/17/2023. And then you store it in the database that the encrypted, really hard to use that without air quotes, the encrypted password, the last password so we can compare how different they are, and then the key, last change date. And the password expiry was 30 days. There are only 30 possible values for the key, and they're stored together. Key in the clear. And so, no salt, really far removed from AES KDF with the key and the salt and the iterations. And now what we have are really, really bad password crypto in implementation. Oh, wait, there's weekends. It's only 22 values that it could possibly be, not even 30, right? Because people don't work on the weekends, so really easy to try. And actually, if you look at it as well too, like the year doesn't change very often at all. So a lot of that is You can actually compare the passwords across each other. There's no salt. And so all sorts of failures. And we went from a supported commercial software with I don't know how many implementations to a complete hack job. So my answer, of course, is put it back now. What are you doing, right? Was the auditor wrong? No, they were actually correct. RACF does not detect substantially similar passwords. But who said it had to, right? Multiple failure modes here, creating your own primitives. Again, the trail of tears that so many have in custom implementations. And ripping out a commercial security product to replace it with a script. Never good. That should be all sorts of red flags. And in this case, appeasing the auditor trumped common sense. Another failure mode, and this is so frequent, snake oil. I really need to touch on snake oil. And if you've not heard of Crown Sterling, they made the press in a way they did not anticipate as a sponsor at Black Hat. And I think they actually had quite a lot of negative press over it. And I'm not saying that they have bad crypto. What I'm saying is that few have made such bold and outrageous claims that they have. And if these are true, then it deserves a heck of a lot of attention. I provided the YouTube link so you could watch and see what they actually published as their YouTube video, which that's a picture of that. And then they had a cocktail hour where the guy talked about how he came up with this methodology. And by the way, the slides for every talk will be made available. I think they hit probably Wednesday night, Thursday, so a couple days away. So if you look at some of the claims that they have, a new understanding of how mathematical constants interact with primes and quasi-primes, which I've never heard of a quasi-prime, to propagate and mirror reflect in infinite wave conjugations. It's an entirely new classification in data privacy called quantum encryption. Oh, I've heard of that. It uses infinite variation within music composed in real time with artificial intelligence and entangled with mirror symmetry mathematics and value, time exposure, and oscillation speed. I didn't realize they could actually affect the oscillation speed of molecules in that way. But okay, we'll presume they can. They changed the nanoscale of time, and where it really jumped the shark for me, one key from the past, one key from the future. You're going forward in time? Doc Brown, anybody? DeLorean, 88 miles per hour, 1.21 gigawatts. I mean, this is like, unpredictable by any known intelligence in the universe. And it's like, okay, now, I'm not saying this isn't real. Now, they've been very quiet in the 3 years since. But this is the biggest collection of red flags I think I've ever seen. And it's a great case study in danger signs, okay? We've already talked about some of the danger signs for snake oil. We have this brilliant genius who's good at math. Sorry, that's not a cryptographer. Secret algorithms. Never a good sign. It's just NISPEC AES using standard Java. And if you don't know why that should make your spine just get chills down it, I've seen this time and again, like, oh, we just used the NIST spec and we coded it that way. And like, oh, good Lord. Okay, that's like understanding how an engine works, internal combustion, and then saying, let's just put what I would design in my lab just from my knowledge of that into every Ford. And there might be a few problems with warranties down the line because there's a lot more to the thing than just it goes bang, right? There's a whole lot more. New cryptography, this is not where you think, ooh, new car. No, this is new medicine, and nobody's tried it until you. Would you care to try that? It's like, nah. And I'm sorry if you're an animal rights activist, but I'd like a rabbit to try it before me. I'm sorry. Because new pharmaceuticals, not comfy territory, right? And that's how you should think of new cryptography. Like, ooh, I don't want to be the first. And they refuse to disclose details. I've literally done this a few times, where I literally will fly to the site, go into a conference room under NDA. I take nothing in the room except the clothes I'm wearing. They show me the documents. I take no notes, and I walk out with an impression. 2 companies have taken me up on this, and many, many, many have refused. Because I'm thinking, like, if it's that secret, like, that's all I can do. There is nothing further I can do than that. And if I go in with that, then there's a possibility I can trust your algorithm. But if you won't even do that, then we're done. And are not certified by a cryptographer. Bruce Schneier has a great quote. Great, I like it, but who are you? Like, what papers have you published? Is that peer reviewed? What do other people think of your work? I mean, show me some of your algorithms in your work, and you know, great, you're a chess master, but you know, who are you? Name dropping, the DoD uses it. They also use Fords and pencils and bananas and all sorts of things. And just because the DoD uses it does not make it super duper, right? They have security experts. I've not seen Ryan Reynolds yet back anything besides Aviator Gin, but just because celebrity endorsements or you know that they come with some big name backs it doesn't necessarily mean that it has strength. They use technobabble obfuscation, you know, the quasi-prime hashinator. It's like, oh, what? Trust us. I've actually had somebody say that one. Trust us. No, it doesn't work that way. Infinite key space, run. There is no such thing as infinite key space or perfect security, either one. Revolutionary new concept, again, that's like, you know, space age formula. Oh, so this is like since 1962 then. That's not that recent. And military grade cipher. Oh, like Vignere, right? Or Enigma? Yeah, okay. Caesar, the Caesar cipher. That's a military grade cipher. Again, the military uses lots of things. They use, you know, ham and hot dogs, just like you do, right? So, yeah, that doesn't really mean anything. Ours is better because theirs is insecure. Well, now you've shown a character flaw at banging away at your competitors instead of demonstrating your own strength. Provably secure using one-time pad. I've had that one before. It's like, oh, really? Yeah. Or just add this and you're done. We're not gonna integrate the crypto along the way. Just, you know, spray this on the end and everything's fine. No, it doesn't work that way. Recoverable keys. For those of you that may have not seen the news, it's worth looking at the splash that the Liberty Safe Company got into recently. And it turns out that when you have electronic locks, they were shipping them with recoverable keys. They have some very angry customers right now. I said, whoa, you mean somebody else has the combination to my safe? Yeah, not good. And they didn't disclose that. So yeah, recoverable keys. Those are called backdoors. Clipper chip failed for a reason. We all didn't like that very much. Or it's a COTS feature we'll just throw in, not a good sign. Foolproof products, usually built by fools, and crypto vendors that don't understand key crypto concepts. Now, with a word of caution, what this means is this is not the time to pound away on the vendor and you know to play alpha geek, right? But you ought to ask reasonable questions. You know, oh, this is a block cipher. Well, how are you handling protection of subkeys? And if they don't know what a subkey is, there's a problem because that's a foundational concept, right? So it's not playing gotcha. It's just, you know, digging away a little bit and having questions. More failure modes. It's additional reason why crypto systems fail, and there are many slides in the appendix covering some of these things. So I gave you about 30 slides extra. We're not going to cover it today. Toolkits matter a lot. They really do. So choose one wisely. Wrong person in the wrong chair. You know, this brilliant programmer, not a cryptographer, right? You need to have the right skills. Vulnerable libraries, big issue. Shortcuts and clear text secrets. You'll see in the appendix, I actually do an annual search for how many instances of, say, rot 13 of the word secret I can find on the internet, or of password backwards, that's rot 13, or MD5, et cetera. And there's a lot. There's a lot. And actually, some of it's actually going up. Most of it's going in the right direction, but some of it's still going up. Additional reason crypto systems fail. You know, there are engineering gaps and development gaps and management gaps. You know, downloading something off the internet, shove this in, whoo, there we go. It's on GitHub, must be good, right? Not a good way to build a crypto system. Insufficient reference to published knowledge when engineering the thing and figuring you can find your own way. Danger, Will Robinson. Management gaps where they don't understand the grasp of probabilistic analysis and how that plays into testing and with risk management. And keeping things around longer than they should. Remember that one of the early questions we talked about is how long does this need to remain secure, and does its need for protection increase or decline over time? And you know, all those questions like for how long? Those should actually be pointed out to your compliance team. So let's talk about turning the corner and avoiding some of these mistakes. So a successful crypto project, if we look at some of the typical goals, you know, are you trying to achieve compliance to meet safe harbor? Are you trying to comply with like PCI DSS or HIPAA with NIST 853, whatever it is? You're going to improve access controls, deal with the audit finding. You're going to protect things in storage. You know, understand the business goals, obviously. And then, you know, obviously you need to deliver controls that provide an expected level of protection, not perfect protection, but an expected level. This is the risk reward. Risk-adjusted return on capital, RAROC, better than ROI. And deliver controls that meet external scrutiny so that somebody from the outside can look at it and understand not only why you did those things you did with the controls you did, but you have a compelling narrative in case there's an incident of decisions that you made, because you may have to have those discussions and disclosures. And controls that do no harm, over-communicate, test, make sure there's operational controls and capabilities, because the last thing you want is to have an incident and say like, I can't get you back to where you need to be. Your database is encrypted and I don't have the key. Not a comfortable conversation. So begin with the end in mind. Make sure that you're talking about risks, not controls. Of course it will have controls. The better discussion's on risk. Make sure that you're looking at really solid requirements, and look at those the entire delivery team, and then bring in all the associated parties that have a dog in the hunt, right? Is the chief privacy officer and their team, you know, and make sure that that all the requirements for that regulation are actually understood. Make sure involving risk management and audit, the line of business, maybe the BSO in your organization, support, disaster recovery, and on and on. And make sure that you're prioritizing risk management and quality into the project. Key management, of course, is imperative. Thank you to the keynote folks for pointing that out, that how important key management is. NIST 857, a good read. I'm not going to read you what's there, but it does point out that it's essential. Kirchhoff's principle, it needs to be as completely reliant on the key for protection. And ultimately, you're trying to make sure that the key is available, that it is confidential, and that it has integrity. Because if you lose any three of those, bad news. And now the good news is that NIST provides really good introductory documentation. Bad news here is attacking a crypto system's key management is probably the best target you can make. So the key management itself is much more likely to be attacked by any attacker that knows their salt than attacks directly on the data. So attacking the key management and the controls, the implementation, the weaknesses that are there is most likely to be the path in. And there's no one size fits all. There are some general principles that can be applied, but nobody else can design a key management system and then hand it to you in your own organization, meeting your business goals, because it has to be aligned to your business. Engaging a cryptographer, start with the end in mind and make sure, and this is, again, I said don't build it, but sometimes you have to, and I've had to. It's not much fun. But make sure you understand what you're trying to do. Trying to break a crypto system, well, that requires a cryptanalyst. Are you trying to create some cryptographic primitives? Hopefully you don't have to, but sometimes you do. And at that point, that requires a cryptographer. Those are different skill sets. Or you're implementing COTS cryptography. Well, then you need a cryptographic implementer that knows how to achieve that. So understand what you need as far as skills. All of these are different. Does your project manager, do they understand security projects? Do you have a security architect or engineer that's engaged that understands cryptography essentials and knows where those dangers are? And you almost likely will need more than one. An example I had to do a PCI DSS database encryption project because one of the problems with tech debt is you sometimes have to do things you don't want to do, including building crypto systems for really old Sparky databases. So there was nothing supported by the vendor that was secure, so we had to do our own. And so we had to, based on the OS it was on, we had to do our own pseudo-random number generator because the old Sparky OS, so hired a cryptographer for that, a cryptographic implementer for the key management system that we put in, and then a cryptographic programmer for the database programming. And then we kind of wrapped the engagement with the architect or engineer. Cryptographers are shockingly expensive. They are really expensive. Like they're sometimes $1,000 an hour, right? And you don't want to have them like writing implementation documentation or mundane project tasks are not what you know you're burning $1,000 on. You want something that costs a lot less. So make sure you have the right people in the right seats in your engagement and wrap the engagement in that way. So segregate the works to permit each expert to do the job that they do best, and you know, have the security engineers on the project do a lot of the heavy lifting for gathering requirements and determining test cases, et cetera, so they can do a lot of that work. Vetting cryptographers. If you're not spending at least an hour discussion in total, and I would recommend probably 2 on vetting your cryptography, you're probably not spending enough time. You need to ask some open-ended questions. You need to ask them to demonstrate what similar things have you done. You know, show me what you've done on the project similar. If it's in person, it's whiteboard timing. You know, show me that similar system. Make sure you're looking for the baloney meter and the snake oil indicators, any red flags that are in there. You probably won't find any, but you might. Don't get starstruck by the fact that, you know, it's NSA or GCHQ, NRO, any of those kinds of things. They put on their pants the same way you do, one leg at a time. And just because they work for the NSA doesn't make them super, right? So you don't need ninjas. Go for what they've actually done. And yeah, an important point is, how do you know when crypto systems go wrong? One of the harder aspects, besides the cryptographic primitives, which hopefully you never do, but even using COTS, how do you test it? Well, most ways it tests, the developer says, oh, let me encrypt this with the key. Ooh, that looks really random, whatever really random means. Let me decrypt it using the wrong key. Ooh, that looks even more random, or at least comparable random. Let me use the right key to decrypt it. Ah, clear text, my work is done. No, but how are you going to test your crypto? It's not easy, and I recommend farming it out. Find experts that have actually developed test cases for testing cryptography and actually have vetted cryptography, and use commercial entities for that. That certainly will stand you in good stead. And make sure you're using NIST standards for cryptographic valuation as well too. So wrapping things up with some application slides, kind of bring us all home. Management needs to hear about data protection and key management. They don't need to hear about cryptography. Keep the discussion on risk. Talk about capabilities, about implementation and documentation and processes, about how things will operate in differing modes and impaired modes. And are you actually testing the recovery and continuity? Layered controls mean more than key space. And again, use risk analysis to figure out when the cryptographic big guns come in, because custom crypto systems require a lot more certification. And so you need to use that as a last option. I encourage you not to, but sometimes you have to. Avoid vendor snake oil. Make sure you're asking the right questions of people to detect those things. Test the cryptographic operational functions. Make sure that whoever is operating it knows how to actually change keys, how to rekey the database, and when you have to change the keys out, do you have a test database you're actually testing that are going to rekey and test a key event? Do you have the means for validating the keys are still securely off-site? And I like physical for that. Like, I put them on DVDs and a USB drive in an evidence bag in a box with evidence tape, and I ship it off to Iron Mountain, because I don't want to rely on anything electronic at that point, because my networks might not be there. I might have a smoking crater, right? So, hey, we're going to go visit Iron Mountain once a year and say, yep, box still sealed, open the box up, it's still in the envelope, reseal the box, re-sign it, paperwork, put this back in the vault, we're done. And you don't have to go high tech for stuff like that. But how do you know that's still valid? How do you know that one of your key escrow people hasn't passed away or left the company? You have to have processes in place. So make sure you're training your admins on these functions regularly. And that leaves me with my closing remarks. If there are any questions, and I think we're right up on time. We have like 4 minutes left, 5 minutes left-ish. 1 minute left. Yes.
So, how do you build confidence in your COTS providers that use cryptography, that they're using the right crypto?
Right. Yeah, and so what you want to do, I mean, it's, you know, like we don't have any luck grilling, you know, AWS on their security model. You know, we have to look at their certifications that they have. So that's how you accomplish that. If they're big, you know, look like, okay, let me see all the certifications you have. Who signed off on your cryptography? Let's look at the papers you've actually published. Can you show me your cryptographers? Like, who do you have on staff, right? RSA got caught a few years ago because they bled out some of their crypto talent. and they had a breach, right? They had an incident because they let a lot of their cryptographers go. So they at one point they were king of the hill, and they fell from grace in that moment because they no longer had those crypto guys around. So yeah, it's a difficult question, but it gets really into third-party risk management. Not ducking it, but it is a hard one. So you have to basically look at the certifications they have and who says yeah they're good. Yeah. Now we are up at the end of time for the official part, but like I said, this is the only thing standing between you and beer at the museum. So I'll be happy to answer questions down front, and thank you for your time.